and 2 is wrong. Now, how many of you think if we added one more electron to this system, everything would be a happy camper? How many of you think if we remove one from this system, it would be a happy camper? Let's see what happens if I remove one electron and make this OH plus. Does that fulfill the octet rule? It does not. Why not? Because oxygen now only has 6 electrons. But if this system gained from the outside world one more electron, then are we happy campers?
Yeah. Yes.
Yes. And so hydroxide always takes a negative charge because it wants that one more electron to fulfill its orbitals. Now, we are going to write the formula like that. But the Lewis dot structure, to show that I added an electron out of nowhere, I'm going to put a minus sign there. So it's going to get brackets, and then it's going to get a minus sign. Why did I do that? Because at the end, my beginning number of electrons did not match the number that I ended up with. I needed one more. Yes, sir.
So every time you add something, it becomes negative. Every time you take something, it becomes positive.
Right, because you're adding or taking away something that is negative. Good question. So like I added -1. So let's do another one. NH4 plus. So NH4 is ammonium. And it exists as an ion with a positive charge. Let's see why. So I'm going to forget about the positive charge, and I'm going to go through my Lewis dot structure. I have nitrogen. I have hydrogens around it. How many valence electrons does nitrogen have?
5.
Nitrogen has 5. Okay. Now, easy street, right? I'm going to add up the number of valence electrons, which is 9. 9, usually a bad number, right? Because it's not even, it's nowhere near 8, like it's not, just have issues, okay? Now, I'm going to connect the dots. What's my issue? There's one extra electron. It's right there. And nitrogen now has 9. What's the easy solution? -1. You lose this electron. If I lose that electron, then this overall becomes positive. Why is it positive? I've lost something negative. I become more positive. It's like when you live your life and you realize that you're just like dwelling on. Is there a problem, Andrew?
No, I just need
Do you not want the life application?
No, I just need
oh,
to
I'm
say
sorry.
something.
No life application
No, go
here.
ahead.
I'm just going to put the cone of silence here. That has many of the really hard characters to draw backwards. Like S is hard because you can't just draw it, you have to do it. And then E's are hard. E's are really hard to do because you write E, but you have to write it. So it shows up there. Okay. When you have somebody who's like really, really negative, they're just a negative person. Like constantly, everything they say is just negative. Man, I hate this, I hate that, I hate politics, I hate, right? Like, and they're just always negative. And then they start giving some of those things up. Man, you're more positive today. You're more encouraging. Thank you for that. But as people like take up new things to complain and talk about, they become more negative, right? So, same way here. We got rid of our electron, we become more positive because we got rid of something negative. Okay? So, NH4 does live positive ion. Let's try NH3. On your own, go ahead and do an NH3 and see if you can find the charge. Excuse you. Is having fun. The teachers all love it. Fun, cool. So if you scribble with pen, you're the reason why people don't allow pen. You cross it out, then you're fine. People are like, anytime someone talks about pen, they're like, no, people will scribble. It's like, okay, fine. Better than erasing, using all your words, not knowing what you're doing. Anyways, it's okay. You pencil people, you're fine. Okay, if you tried to make this an ion, it didn't work, right? Nitrogen, 5 electrons, 3 hydrogens. 3 plus 5 is 8. We see our magic number already, so that's it. It's not an ion. That's ammonia, in case you're wondering. Like the stuff you use for cleaning at home. Yeah. No, because I want 8. 8's a beautiful number. You guys doing okay? Sure? There's something on my nose. Oh, sorry. You guys don't clean at home?
Not really. Why?
Ryan, you should be cleaning.
He's the oldest. That's why he has younger siblings. Clean for me. And
It's
then,
the opposite.
oh,
Older
he should be a
siblings
servant.
clean.
Interesting. All right, so moving
I
on.
clean before the nurses.
Let's talk about
Sounds
ionic
so
bond.
funny.
Oh, wait. I wasn't, but I should have.
Angry. That's his prayer face.
Yeah, that's
Okay.
perfect.
So let's talk about ionic bonds now. We're going to move away from that for a little bit, and then we'll come back to it later. Probably the next chapter. So ionic bonds, their strength is given to us by the change in electronegativity. Delta is the Greek symbol for change. Well, we use it as, it's a Greek symbol, but we use it for change. Oh, time to give homework. En stands for electronegativity. So the change in electronegativity dictates how strong is an ionic bond. So you can look up electronegativity values for each element and then determine their strength by determining the difference of their electronegativity. There's a table for that. If you want, it's on page 124, if I'm not mistaken. Is that true? It is true. So on page 124 in your book, there's a periodic table with the electronegativities there. And then you can see how the strength of these ionic bonds relate. So some ionic bonds will be much stronger than others. So let's do sodium chloride. This is an ionic bond because we have metal and nonmetal. If I want to know how strong this is, I would find the change in electronegativity. So I'm going to take sodium, which is a, or sorry, I'm going to take chlorine, which is a 3.2. Very electronegative. It wants to gain that extra electron, and I'm going to subtract sodium, which is 0.9. Again, these are from the table on page 124. And so we get 2.3. So that number means nothing unless we compare it to something else, right? And then we can compare their general bond strength. Cool. And I'm out of time. So your homework, the work that you will do from home, is page 162, numbers 6. Is that it? 4 and 6. All right. You have like 1 minute.